Okay, good. So let me know. I'm going to share my screen. You let me know when it is visible. Okay, I hope my screen is visible, right? Hello. Someone is.
Yes, I can confirm. We can see
Okay, good.
statistics for data science.
Okay, thank you, thank you. All right. So during the that is the class, you can also mute so that we might not have background noise, which might affect that is the recording. Okay. All right. I think we are good. So welcome to statistics class for data science. As I had said earlier, my name is Abraham. And this is what we are going to cover during or throughout our statistics class. Of course, we are going to start with something we call descriptive statistics. Okay, I know most of you know what it means by descriptive statistics from the term that is descriptive. Okay, we can say it is more of describing. Okay, so under the descriptive statistics, we will that is will know that it is majorly a summary or majorly describes about that is characteristics about a certain what a certain data set. Okay, it's under descriptive statistics where we'll come to learn that is different measures of that is measures in statistics, like we have measures of central tendency where we have mean, mode, and median. We'll also learn about measures of variability, or yeah, measures of variability, which is now variance and standard deviation. Okay, we'll also talk about measures of that is asymmetry. Okay, and measures of asymmetry we'll discuss about that is skewness and kurtosis. Okay, so majorly those are some of characteristics which we can use to describe what to describe a data set. Okay, yes. So we'll also come to inferential statistics, and under inferential statistics from the term infer. Okay, like we are making conclusions. Okay, out of a certain output. Okay, and under inferential statistics, we usually have hypothesis testing. Okay, and also we can say distributions can be categorized as inferential statistics at some point. We'll also discuss more in regression, and regression, make sure you let's underline this, that is regression. Okay, regression, it's a major topic in statistics because it is under regression where we'll be that is creating predictive models, or when you will be now learning machine learning, you will interact more with regression. Okay, that is the linear regression and also logistic regression. Okay, so for our class we will discuss that is only linear and multiple regression. Okay, for logistic regression, you will study it during that is the machine learning topic. All right. We'll also discuss about correlation. That is the relationship or the strength of relationship between what? Between two variables. So we'll talk about correlation and also covariance. We'll also talk about exploratory analysis and also sampling. But under sampling, we'll just do some highlights. That is different methods of what? Of sampling. Because we won't do much of practicals under sampling because they will need that is more of simulation, which is on advanced level. So the other thing, I think I've already covered or highlighted all the topics which we are going to discuss during our statistics class. All right, I think we are good and we are now ready to start our statistics class. So in statistics, we usually have different types of data. Okay, that is in statistics, and these types of data, we in fact we usually have two major types of data. That is qualitative and quantitative. Okay, qualitative and quantitative, whereby under qualitative and quantitative, they are further subdivided into what? Into different categories. Okay, like for example, let's start with quantitative. Quantitative from the term quantity, meaning we are talking about numbers here. Okay, we'll be talking about figures. Okay, yeah, so under quantitative, we usually have discrete data and also continuous data. I know most of you know the difference between discrete and continuous data, but with that, we shall also discuss that that is in a different slide. Okay, so majorly, I was trying to show you that is different types of data in statistics and how they are subdivided. Okay, all right, so let's start with the basic definition of data. Who can define for us data? Someone who can define for us what is data, or what do you understand by the term data? Anyone? Someone? Can you hear me, guys? Please, someone to confirm if I'm loud.
Yes, you can be heard. Yes.
All right. Oh, nice. Oh, nice. Because sometimes network might decide to do its thing, and yeah, so that's why I usually need confirmation. And in case maybe you lose me, always you can always call me via WhatsApp, or you can always text me on WhatsApp. All right, someone to define what is data. Okay, don't be afraid. No right, no wrong question here. Okay, yeah, we'll argue and see which is the best way to define data. Someone, I don't want to pick to randomly pick people, but let's make it a volunteer thing. What do you understand by the term data? Data. You usually say data. I want to do data science. I've enrolled in a data science course. What is this data? Hmm. Anyone with idea? Yes.
Data, I think it's collection and research of information.
Collection and
And research.
research of
Research.
information. Once when you said information, that's when I disqualified. That is, I disqualified your definition, because we usually use data to get what? Information. So in this case, we can't say data is information,
Okay.
because once we process the data, it's when now we get the information. Yes, please.
Yeah, true.
Yeah, someone else. Someone raised. I don't want to go back to the meet, because it might. Okay. Yes, Nancy. Nancy.
Okay, just a trial that data would be like numbers of items, figures, ideas,
Mm-hmm.
you know,
Yeah, of
all
course.
that
Yes, they can be
items.
yes, they can be figures. Very correct. But with, let's say, raw figures. Okay. Yes. Then Salome. Salome Mueni. I can see you raised your hand. Okay. Okay. All right. Okay, good. So let me help you understand that is data. So we can say data is a set. Okay, it is a set of facts. Okay, data is a set of facts or figures that can be used to get information. Okay, or yes, that can be used to get information. That's a correct that is definition. Okay, so data, we can say data is a set of facts and figures that can be used to, or that can be processed to get information. Okay, yes, that's basically, or that's the best definition of data. So data is defined as, let's see what our slides um, is telling us about, that is data types or data definition of data in statistics. So data is defined as a systematic record, okay, responding to a specific what? Quantity. But that's very, I can say that is a complex one. But basically, data can be summarized as it is a set of facts and figures which can be used to serve a specific usage or purpose. But we can say data is a set of facts and figures that can be used to, or that when processed can what? Can give us information. Okay, so for instance, data can be used as a survey or an analysis. Like for example, we can obtain data from a survey. Okay, or from yeah, a survey. It can be either online or physical, where maybe you are now going to, that is to the field to collect the data. Okay, yeah, but it can be also an online, that, or a digital way to collect, like when you are using Kobo Toolbox. Okay, which is a mobile way of, or a digital way of collecting data using, let's say, an application. Okay, an installed application. So data is systematic and organized form, or data in a systematic and organized form is now referred to as information. That is, those are some of the processes. Like if you do now the analysis, you can do what? You can get information from the data. So in addition to this, We have primary and secondary sources of data. Like primary, I think these are things which we learned back in high school. Like we can say primarily a source of data, it's like when you go to the field, you interview people using the questionnaires. So with that, you are what? That you will be the primary source of the what? Of the data which you collect. Then secondary, like secondary, if you go to that is online right now, you can get that is any kind of data you need. You can get COVID-19 data. You can get financial performance of different companies or of different stock prices. Okay, online. Okay, so now that will be what? A secondary source. Why? Because you did not that is someone else collected that data. Okay, yes, or someone else or another system collected that data. So I want us now to go to the different types of data. I hope all of you have understood what it means with the data. And from now henceforth, in case someone asks you to define data, you can do what? You can define data. Okay? Yes. All right. Now let's go to different types of data. Of course, I had said that in statistics, data or data types are subdivided into two major categories. Okay, that is qualitative and quantitative. Okay, and then let's start with quantitative. Uh, Quantitative also it's further subdivided into two, that is discrete data and continuous data. Okay, can someone give us the difference between discrete and continuous data? Can someone give us the difference between discrete and continuous data? Someone. That is the team who the team that was under intermediate. We have Claire, we have Fiona, we have Collins Odwor, we have Ephraim Mpua, we have Rachel Simiyu, we also have Salome Mweni. So we are depending on you, please. Since already you have basic knowledge in statistics, we need your contribution here. Don't shy off. Don't shy off. Just unmute, and then you define for us or you differentiate for us. What is the difference between discrete data and continuous data?
Okay, good evening.
Yes, good evening.
In my opinion, I think discrete data is data that is counted and has a limited value, like you can count it, but continuous is unlimited. Yeah, and mostly it's in numeric value. It's almost any, like it's just continuous, infinity.
Oh, so what you are trying to mean is that we have that is for discrete, it's finite. For continuous, it's infinite, right? Meaning for discrete, it's countable. For continuous, it's uh,
Measured.
non-countable or not count. That is, you can't count. Okay. All right. So it's a true point. Yeah, it is true. Someone else? Uh, is it we have Brenda? Uh, who gave us the first response? Okay, so we have Salome, we have Brenda. Okay, I can see your answer up. Salome or Brenda, anyone. Okay, Brenda.
Another difference between a discrete data and continuous data is that
Mhm,
discrete data is exact, like
mhm.
it doesn't change, but for continuous data, it can change. For example, the weight of a baby. In its
So
first year,
for the weight, it's what?
in its first years, it changes, but as it continues to grow,
Mhm.
the weight of the baby changes.
You gave us a good example. You gave us a good example, but I won't maybe I won't take that. That is on the varying aspect or the changing
Okay.
aspect of your point. But the example you gave us, it is a good example for continuous. Okay, it is a good weight. Is a good example. Yes,
Okay.
yes. Um, let's go to Ephraim. Ephraim.
Yeah, good evening.
Yes.
Discrete data is a measure of exact values,
Mm-hmm.
whereas continuous is a measurable difference of a number of figures, like maybe height in a class.
Height in a class, that's continuous, of course,
Yeah,
because
yeah.
but imagine I'm going to give you the simplest definition you can. So let's start with discrete. Discrete, we can say we are talking about all numbers here under discrete. Okay, no decimal is attached to the value to discrete values. Okay, then for continuous, it gives us more of a range, or we have even some decimals attached to that is to the values. Okay, and another definition which I will take, it is that discrete it's countable. Okay, discrete it's countable, you can count. Okay, for continuous it's not that easily countable. Okay, like let me give you an example of a discrete. In this class, how many people, how many students are we? Let me call you students because we are all in this statistics class. For now, I know you might be very you might be prominent guys. We are mixed up here. So, but let me just use that example. Or how many are we in this meeting? Of course, we can't say we are 5.5, right? Or we can't say we are 5.7. Okay, but it is exact. It's either 10, 20, 30. Okay, no decimal is attached to that value, and it is countable. You can count. Okay, yeah. So that's the basic. That is the basic best definition of discrete data. It is countable, and it is presented as a whole number. All right. Yes. Now let's come to continuous. That is to continuous data. Okay. Like for example, let me give you an example of the height in a class. Of course, you can't we can't all have exact what exact height. Okay. So you'll find someone is that is it is 150.3 centimeters, 156 point maybe 6 centimeters. Okay, there is a float. Okay, or a decimal attached to that value. A float basically it's a decimal. Okay, so we have that is a decimal attached to that value, and again it's not easily countable. Like for example, if I tell you I want you to that is to count for me the values between 0 and 1, can you really count the values between 0 and 1? Remember, that's a range. Okay, we have 0.0000001, 0.0000099. Okay, so we have more than a million values between 0 and what? And 1. Okay, so that's a range. So still it's under what? It's under continuous. All right. Okay, then we have I hope that is clear and you can differentiate that. Sorry, today I'm using that is uh, a laptop which is kind of okay, but tomorrow I will use a better one that I can use to highlight, I can write comments, I can do some notes. Okay, yeah, so don't worry, I think it's because of the version I'm using, that is, just a minute, check. I think it's the version I'm using. It should be 365. So 365 has those features which can help us to do some comments, highlight. But don't worry, tomorrow we'll have something which to illustrate. Okay, I love illustrating because for me to understand, I usually need illustration. Okay, even in a class I really love illustrations. Okay, so I want us to start. That is on qualitative data. I know qualitative data. It is the major confusing and major. Let me say confusing and sometimes hard to understand. Okay, the data types. Okay, that is the nominal and the the ordinal. Why? Because now under qualitative that is data, we now don't measure data using numbers or using figures, but we use attributes, okay, to explain about that is about a certain data. Okay, we use attributes. Attributes are basically characteristics. Okay, like for example, if I say the meal, it's so delicious, what, yeah, so with that, I'm not specifically using what? Numerical. That's why we usually say that for qualitative data, they are usually non-numeric in nature. Okay. Yes, so let's start and get to understand. So make sure here you pay consideration, ask questions where you don't understand, okay, so that at least we may move together. All right, so I want us to finish the quantitative data in the next few minutes before we can proceed to a short break. Okay, so quantitative. So quantitative basically is used to represent some characteristics or attributes of a specific data or of a data set. Okay, so here we are talking about that is characteristics. Okay, like for example, if we can talk about characteristic of let's say of a gent or of a lady. Okay, you can talk about that is he is tall, she is beautiful, okay, she's loyal, she's wise, depending with the arguments. Okay, so with those are just attributes, and they cannot be measured. You cannot measure those attributes. Okay, yeah. So the facts and the figures depicted by the qualitative data cannot be computed. So you cannot compute or you cannot calculate the facts and the figures which you get from a qualitative data. Okay, so these properties reflect observable attributes. These are qualitative data are non-numerical in nature. Okay, they are non-numerical in nature. But now that's where the confusion comes in. We've said they are non-numerical in nature, but there is a way we can assign values to the what? To the non-numerical values, or not values, to the attributes. Okay, like in gender. Okay, I think most of you have ever interacted with SPSS, whereby you can always assign a value to a variable. Okay, let's say we have a variable gender. Okay, and under gender we usually categorize zero, that is male and what, and female. Otherwise, we can also use 0 to indicate male, 1 to indicate what, female. Okay, so with that you can see we initially add a qualitative data in nature, that is male and female. Okay, but we have assigned some values to those variables to make them now quantitative. I think I'm not confusing you much. Okay, that is, even though uh, qualitative data are numeric in nature, there is a way we can, but for some, not for all the what, for all the data. Okay, but sometimes we can assign values to those attributes. Okay, to change it from qualitative to a quantitative data type for analysis purposes, but we shall check that. So the qualitative data characteristics are exploratory on a larger end than being conclusive in nature. So they majorly explain about something. They are more of explanatory rather than what, conclusive. You can't come up with a tangible conclusion. Okay, because you can't do the analysis. Okay, for instance, data on attributes are like honesty, loyalty, wisdom, and creativity. For a set of persons, defined can be considered as what? Qualitative data. So those are some of attributes which we can use. Okay, so and under qualitative data, we have some examples like the attitude of people to a political system. You can also do a survey like to get the opinion, that is the opinion rolls. Okay, or to get the attitude of people towards a certain political system. Like for example, now we are having UDA, okay, in Kenya, that is in Kenya. So of course, everyone has different attitude toward what? Toward the government. Okay. Yeah. So with that, we can do what? We can term that as what? Qualitative in nature. Also, music and art, intelligence. That is you can rate, or you can try to explain intelligence of someone. Okay, maybe you can say this person is wise, this person is foolish. Okay, so though intelligence, yeah, you can try to classify. Okay, yeah, then we have beauty of a person. Okay, Okay, just a minute. Don't know who is calling me. Maybe it might be a student. Hello. Hello. Okay, let's continue. Sorry for that, guys. Okay, so I want us now to go to the that is the specific qualitative data types. So we have nominal data. Under nominal data, what are we really talking about? Okay, so we can say that nominal data is of course a subcategory of qualitative data. Remember, under qualitative data, we say that qualitative is further subdivided, okay, or subcategorized to nominal data and ordinal data. Now we are under ordinal data, okay. So, and under ordinal data, it's also known as nominal scale, and it is used to label the variables without providing the numerical value for them. So, like for example, nominal data attributes can either be ordered, can't be ordered or measured. So in this case, we can't order or measure. Like for example, under gender, you can't order gender. Okay, you can't order eye color. Okay, you can't order marital status. Okay, as you can order maybe some ratings like customer satisfaction. Okay, of course you can order that. Okay, because you can be dissatisfied, you can be satisfied. Okay, or yes, I know you've ever come across such structured questionnaires. Okay, so under nominal data, you can't order. Okay, so this is the major characteristic of nominal data. You cannot order and you cannot measure. Okay, yes. So the nominal data can be both qualitative and quantitative in nature. They can be both qualitative and quantitative in nature. As we have said, it is used to label what? To label variables. Okay, like for example, nominal scale. That is nominal data, or it is used to label the variables without providing nominal value. Like for example, we have gender. Sorry, under gender. Okay, just a minute. We have gender. Under gender, you can see it is now subcategorized, or it is labeled. We have labeled some of variables under gender. Okay, like for example, we have women and men. Okay, these are what? These are variables under what? Under gender. And you can see with that, we've not provided what? We've not provided any numerical value. Okay, to what? To the nominal data, that is gender. Okay, but remember now, not this statement. Okay, I want you to note this statement. So we've said that nominal data attributes can't either be ordered or measured. Very correct. We've said that the nominal data can be both qualitative and quantitative in nature. Now here, that's where we can now assign values to these variables. Okay, that is now converting nominal data to what? From quantitative to qualitative. Now we can do what? We can assign values to these what? To these variables. Like for example, we might say that let 1 present women and let 2 present what? Men. Okay, so with that, you can see now we will be dealing with what? Ones and twos. Okay, and that is what? Those are what? Those are that is quantitative data types. So for instance, some of the nominal data attributes are letters, symbols, or gender, etc. So the examination of the nominal data is based on the usage of grouping method. Okay, that is grouping method. I think they can be in two categories. Okay, of course, you know grouping of data whereby we can use they are called frequency distribution tables. Okay, we can use frequency distribution tables to do what? To group. All right, to group some data. All right, so take note of that. So like age, we can group how many people maybe are within this age category. We can also group gender. Okay, like how many male, how many are female. We can also group maybe if you are given a data set containing German machines like Mercedes, Audi, and BMW. Okay, you can categorize that. Like, how many cells did you make for Audi? How many cells did you make for BMW? How many cells did you make for Mercedes? Okay, all right. So we've said that under nominal data, we usually use, there is a high usage of grouping method, and this method is based on the principle of grouping of data into different category, then followed by calculation of frequencies. Basically, this is the frequency distribution what? Frequency distribution tables, okay, or percentages in data. And majorly we can further that is visualize that data using that is pie charts, and also yeah, pie charts majorly, okay, because it is categorical. Otherwise, we have some examples of nominal data. That is, we have gender, whereby under gender we can categorize into different variables, men and women. We have eye color. Okay, under eye color we can further that is categorized, either it is they are blue, they are brown and green. Under marital status, the same. It's either you are married, single, or divorced. Then we have religion. It's either you are Muslim, Hindu, or Christian. I think I'm much clear under nominal data. Unless you have a question before I can proceed to ordinal data. Any question under nominal data? Any question? Or we are all good? Any question? Okay, then silence means you've understood everything, which is good. I'm happy. Seems I'm working with the best class. That's okay. So let's go now to ordinal data. Okay, let's now proceed to ordinal data. So under ordinal data, we said for nominal, there is no order, there is no measure. You cannot order and you cannot measure. But now in ordinal, you can order, or basically it follows a natural order. Let's try to do some deep dive and see basically what it means with ordinal data. So ordinal data is specific type of data that follows a natural order. Okay, like for example, if we are getting ratings, It's either between 1 and 5, okay? Meaning 1 you have poorly performed, the highest value meaning you are doing good in terms of performance, okay? Also in terms of economic status, okay, we have low, medium and high, okay? Same as grading, okay, that is A, B, C, and D, and also we have F for a fail, okay? And also we have customer level of satisfaction, that is very satisfied, satisfied, maybe neutral, dissatisfied, or very dissatisfied, okay? So you can see we have a natural order, okay? Yes. So now let's try to get more understanding of ordinal data. First of all, take note, it follows a natural order. So the difference between the data value is not determined in the case of nominal data. For instance, ordinal data variable is mostly found in surveys, economics, questionnaires, and finance operations. Very correct. Why? Because, like for example, in questionnaires, you usually meet maybe some that is questions. It's either you can choose maybe satisfied, dissatisfied. We have those options. Okay, so they are majorly found in what? In questionnaires and also in surveys. More, this is more of ordinal data. Okay. So, the examination of nominal data is based on the usage of visualization tool. Sorry, this should be. Oh, yeah, this is like that is comparison between the nominal data and the ordinal data. It's kind of comparison. Okay, so like examination of nominal data is basically in usage of what tools? That is the bar charts and pie charts. Okay, but now under ordinal, that is ordinal data can be expressed in the form of tables which have that is each row corresponding to the distinct category. That is like the cross tabulation. I think you've ever came across the that is cross tabulation, but don't worry about this. I will recheck and also add some notes for clarity before I can share that is the notes with you. But basically, take note of this. It follows some ordered what? That is a natural order. Okay. Yes. So that's all about ordinal data. And if maybe for you not to confuse, ordinal order, ordinal order, you can you can try that is to use that for to help that is to help you not forget that. Any question? Any question? And qualitative data. Any question under qualitative data? Okay. If no question, I think we are going to proceed for a short break. 17 minutes, I think, will be enough for you. Yeah, 17 minutes. And then we'll be back to finish that is on quantitative data. Okay, we'll be now back to finish how many slides? 4 slides. In fact, only 3 slides. If not so, you can decide we finish these 3 slides and then maybe we call it a day. Okay. So I don't know what's your option. We go for let's say 15 minutes break, or we can finish up these 3 slides and then end the class for today. And then tomorrow we will now start that is on descriptive statistics. Yes.
We can finish up.
Okay, I can see. All right. Of course, that's the that's the ideal option. All right. So I think, in fact, I had summarized everything under quantitative data. We've said for quantitative data, we are talking about numbers, numericals. Okay. And of course, under the numericals, we have different representation of the numerical. Some with decimals, others without decimals. Okay, so let's go through these slides a bit quick and see what maybe the notes, what we are getting from the notes. So quantitative data can be measured and is not just observable. The measurement of data is numerically recorded and represented. Calculations and interpretations can be performed and obtain results. Okay, so remember here you can do calculations, but for qualitative data, we said no calculations, no computations can be done. Okay, yes. So and for numerical data is indicated by quantitative data. For instance, data can be recorded about how many users found a product satisfactory in terms of collecting ratings online. Like for example, if you go to that is AfriCDSA, that is African Center for Data Science, this company, and try to check their ratings, okay, on the what on that is online, okay, or by Google. You can, it is very simple, you can go check the ratings and see maybe the previous comments of students who that is took the data science journey with us. Okay, so for us, we can now use those ratings, okay, to do some what, to do some analysis, okay, and also make conclusions. All right, we can collect those ratings. Of course, we usually collect those ratings, and those ratings, of course, have somewhat have some information in it. Like for example, if the rating is high, definitely you will know that the company is doing well, it's offering the best solution and also services. Okay, if the rating is low, then you will be suspicious, okay, of that maybe a certain product or service. All right, and therefore an overall product review can be generated, and we have examples. So we have income, weight, price, daily temperatures. But here now, it is a combination of both discrete and continuous. Okay, like for example, can someone tell me daily temperature? Depending with the explanation I gave you, but maybe let's make it quick. So, of course, daily temperature continuous. Price can be also continuous. It might be like you might be selling a product at 100 point maybe 50, like 100 shillings 50 cents. Okay, meaning we will have a decimal. Then we have weights. Weights can be also expressed in decimal. We have income. Income can also be expressed in that is expressed in decimals. Okay, so some, okay, not all. So this can fall that is on the two types. But now the value will tell you to which side it lies. Okay. All right, then we have a number of that is number of students. Of course, that will be what will be now discrete. Okay, let's go to discrete. So discrete data refers to data values which can only attain certain specific values. Discrete data can't attain range of values. We said range is for continuous. So, and discrete data can be represented using bar charts. Can be represented using bar charts. Okay, so basically, discrete data, it is the data that can only attain specific values. Okay, meaning we have no decimal attached to it. Okay, and it is countable. You can go and try to check, learn more differences between discrete and continuous. So we have some examples. Number of students in a class. Of course, this will be discrete because we can't have 50.6 students. Then we have a number of chips in a bag. We also have the number of stars in what? In the sky. So this is something which we can express as a discrete. Okay, let's now go to continuous data. So under continuous data, we are saying that continuous data can contain values between a range. You can see now here we are talking about a range, and you know a range, it's what? The difference, or it is that is values within the highest and the lowest values. Okay, yes, so the corresponding difference between the highest and lowest value of this interval can be termed as a range of data. Continuous data can be tabulated in what we call frequency distribution table. Okay, frequency distribution what? Tables. We can use to that is we can use we can use to present, okay, to present the continuous data in table forms or in table format. So the frequency distribution table can be computed for the range for a range type of data. It can also be depicted using histograms. For example, the heights of students in a class can be largely varying in nature. So basically, one of the methods we use for data visualization in continuous or when we are dealing with continuous data, it is what? It is that is histograms. Okay, all right. So we have some examples like height, weight of a student, of course, that's a continuous. Daily temperature, of course, recordings, those that is continuous. And wind speed measurement, also that can be presented as a continuous that is data. I think that's all for